Hello, everyone. Let's start talking about distributed generation and schemes for installations in Mexico. My name is Humberto Bustamante. I'm Group Technical Manager of Revolve. Let's speak a bit about Revolve in order for you to understand further what I'm going to show you. So, okay, but first let's revolve a bit. Okay, now we are revolving. Next, a bit of disclaimer just for it to be there. Then, the company background, Revolve Renewable Power Corporation, established in 2012, and we do two main things: utility scale developer. Right now, we are currently developing 12 projects from greenfield to ready to build in Mexico and US, and distributed generation business. We currently have 6 megawatts of operating projects in Mexico. Next, let's go to the next ones, because here we are showing the Mexican utility scale development portfolio, which is mainly wind energy in development, which has at different stages. But before, the company has already developed projects up to ready to build and then sold them to other companies. So the team is experienced, and we are actually looking for developing solar projects, large scale solar projects, which will, as my partner said, right now Mexico for utility scale is a little difficult, and I will come to that later. In US, we are developing a lot of projects that you can see here, at 8 projects in total, more than 1 gigawatt, mainly focused on the west central area of US. So it's not the focus right now, but I'm going to continue. This is the one that is most interesting right now. It's the operational distributed generation that we currently have. It's mainly PV photovoltaic solar systems, lower than 500 kilowatts. There's one that is 900 kilowatts, and we have one best standalone project in Cancun, more than 3 megawatts, and one is cogeneration combined heat and power, also 500 kilowatts. So we are going to come back to this, a couple of cases of these ones at the end of the presentation. So right now, solar development main challenges in LATAM. Frankly, this is just to confirm what Gabriel said. Practically, it's just very, very concise. What's the conclusion? Probably as Mexico, what's the main challenges? Regulatory uncertainty in utility scale certainly is a severe bottleneck. For utility scale, there are several different types of permits: environmental, interconnection permit, but the one that is really the bottleneck is generation permit, which is the one most controlled by the government. So that is the one that is right now not giving the permit to further developments, or giving it very slowly. In Colombia, is interconnection process and availability. So right now there are many new developments, but the availability of the interconnection is difficult right now. And there's also for wind energy, very difficult situation in solar, in social and community acceptance of the projects, especially for La Guajira, where all the wind energy is being developed. So that's also a challenge. For Chile, as Gabriel just said, transmission is the main problem, because it has not been upgraded transmission lines, even as per own law requirement. So this causes severe blockage and disruption in the hourly rates. So right now, I just came from being 2 months in Chile, and everyone is saying that battery storage system is a must-have for new project development. And in Brazil, well, I don't have that much experience in Brazil, but what I see is a very competitive market due to high expected expansion, so low prices. So, and actually Gabriel has just said the same. So this is just a quick summary of what they said. So let's focus on Mexico, what's the current state. Right now, permitting is being very slow, as probably because of COVID delays, lack of clarity and consistency in requirement of the permittings, and rejection of the energy generation permits. So additionally to this, the energy demand is growing by two factors: nearshoring effect that is causing increase in industry in Mexico due to the near process for US, Canada. So it's right now very strategic, and it's growing. The industry is growing, so obviously it comes with energy demand, and also the climate change that is making a hotter climate, hotter sun, a less availability of water, and other challenges. So it is expected at least a 2.5% annual increase for the next 15 years of growing demand. The energy margin in the grid right now is thin in Mexico, and even minor blackouts has been occurring in this hot season. Right now, is really, we are facing hot waves and making this complicated. Newer generation is highly needed, but not allowed in utility scale. So if not allowed in utility scale, we only have distributed generation. The industry have distributed generation, and what are the rules here? Well, for distributed generation, systems can have up to 500 kilowatts. That allows for not going on a permitting process, so you don't have to pass all this process that is currently stalling the developments, or the large scale developments. So one interconnected system, one of these 500 kilowatts interconnected system per energy consumption contract. So some industries have just one, but others, larger industries, have 2 or 3 energy consumption contracts with the grid distributor, which is Comisión Federal de Electricidad, CFE. Therefore, they can have 2 or 3 of these systems interconnected. But also, it's allowed to have isolated generation systems, completely isolated, of less than up to 500 kilowatts, but as long as they are not interconnected with the grid or between them. So that is also an emergency kind of development that is actually being implemented in Mexico. Distributed generation expected growth in Mexico, something has been told, but official numbers just came out this month from the Prodecen report, and it's expected to grow from 2.6 gigawatts in last year to between 11 to 70 gigawatts in the next 15 years. So you can see the curves here. So it is a lot of distributed generation, and these are official numbers from the government plan. So this is moving forward in distributed generation. So let's move into more, what are the rules for distributed generation? Well, right now, what do you need to install a distributed generation project? Well, you need to be feasible. So if you need to be feasible, you need to be better option the current energy fees you have for interconnecting with the basic energy supplier, which right now was only CFE, for low and medium voltage. So above 100 kilowatts, there are different energy type of fees, but the most used is the GDMTH, which is hourly high demand in medium voltage type of energy fee. what is the particularly thing about in particular thing to remember about this energy type of fee, that it has 3 different hourly rates by the time of the day. So I mean, mostly when the energy is mostly in use, you have a base rate. Then during the day, you have a middle rate. Then you have a peak day, which is between 7 p.m. to more or less 10 p.m., which is the peak hourly rate, which is the highest costly energy. Then you have again another part of middle energy rate, and then again after 12 p.m. you have the base energy. So remember this because it's going to be important later. Also, the prices can change according to to 17 different geographies. Industrial energy fees has not only those things depend on the final fee, but also depends of what is your contracted demand. Normally, what is the maximum power you are going to have on your load, then the total monthly energy consumed, and the monthly maximum demand you consume under the last invoice period. So these are very important factors because increase, I'm not going to put the formulas because they start to get a little bit complicated, but the maximum demand you get from the grid and the total monthly energy consuming are important factors for the final fee and not only the hourly rate that we saw on the last slide. Then, just a little point. CFE fees have increased in average 12% in the last year, from June to June. Sorry, this is 2022 or 2023. There's a typo here. But while the inflation was less than 6%, so the currently in electricity rates are moving higher than the inflation. So this is a risk for the industry, and therefore there is an opportunity for distributed generation systems to come and reduce dependency on energy fees increases and reduce dependency on fossil fuel prices volatility. So I'm taking these examples of the different increases depending of the hourly rates and the geographies. So you can see that overall is around 12% in the last year. Okay, so those were the rules of how to install distributed generation systems. Now we are going to talk about what technology options do we have. So the most common option right now is photovoltaic PV, is the one that is increasing, at least in my experience, what I'm seeing that is increasing the most is photovoltaic, because it's a very competitive energy and generates energy on middle fee rate. So during the day, it's normal our production, so it has good energy rate to compensate for. So what is its disadvantage? Disadvantage is low capacity factor. Why this is a disadvantage? Normally, you don't care about your low capacity factor as long as your energy end up being competitive. I mean, if your energy ends up being the cheaper option, which is with a good quality but cheap option, then you are good to go. Well, in this case, the problem is you have a maximum limit of 500 kilowatts on distributed generation. So if you have that and you combine it with a low capacity factor because you have only so much, I mean, around 4 solar hours per day, then your energy generated overall is a little low. So compared to another option as cogeneration for combined heat and power. So what are the benefits? More energy generation, sustained generation, and can help for us, can have the role of backup function. What is the problems of cogeneration? Well, it's dependent on fossil fuel pricing. So it also has that variability and may not align with the ESG corporation goals or the renewable energy goals. So these are the problem, but for sure it can generate a lot more energy than a photovoltaic system for the capacity factor that they can have. What are the third option is the battery storage system. So what are the benefits? Well, almost a lot of benefits that they have as reduction of maximum load, chief of power consumption. So instead of consuming on the peak rate, hourly rate, you can consume on the base energy rate, even if you have no other loads. It can save, it can have the role as backup function, no distributed generation limit capacity. It's not limited to the 100 kilowatts. You can install several megawatts if you want, because actually it just helping the grid, is not causing a problem to the grid. But what's the problem? Well, the problem is the high cost. High capital expenditure. So we will see, it has to be seen for every single case, is it actually feasible or not, and it's actually going to produce savings. So going into what are the schemes of the acquiring digital distribution, distributed generating system acquisition. So you have as an industry, as a final client, you can go with a direct purchase or a leasing system or a power purchase agreement. So a direct purchase, if you are a very big industry and you have a lot of technical guys and you already have maintenance and you want to do an investment, then probably direct purchase is okay, but you have to be aware that is the highest risk exposure for design faults, construction bad practices, or hidden defects. Requires the complete initial investment and requires management of all the operational maintenance of the system. While with leasing, you have a reduced initial investment, probably between 15 to 20% of the needed investment, of the full investment, but you have to manage the debt, and you have somehow, it depends on exactly what are the terms, but somehow you can have complicated contract terms, co-ownership of the system, and then that can bring up some complex relationships and potential disagreements if not well managed. So you can have also some partial flexibility on the system. As with power purchase agreements, you have a lot of benefits. You don't require debt. You don't require investment. No, you don't need to manage debt. You have the lower risk because you only pay for the generated energy. You have the least responsibility, as the system is not of your own. It's from a third party. It's owned by a third party, and you only pay for the energy. That is what they requires the least of the management, because all the management is done by the provider. What is a potential disadvantage? Probably, well, the system is not your own, so you have limited flexibility of what you can do with the system. No? If you want to expand, you need to come to a new agreement or a change order in that aspect. So those are the systems. Moving forward, let's talk about success case studies. In this case, it's a rooftop PV case study. This one is 900 megawatts. It has two contracts to sum up two different PV systems. It's located in the state of Mexico, in the central area of Mexico. It started operation in late 2019. It has 2,400 Logi PV modules, 7 solar age inverters, and it has generated, well, a lot of energy for the system. Is a good system. What are the benefits for the client? Well, it's giving a 70% lower price than the average fee of CFE. So it is estimated to provide 1 million US in savings after 10 years of operation for the plant. And also it has a lot of environmental benefits. So this is a success case study. And then moving forward to the next one, we have the best standalone battery system. In this case, it was only a battery system that at the end for this company profile was the most benefit. But right now we are seeing a lot of projects that a combination of photovoltaic and batteries can actually provide good benefits too. So in this case, it has 3 battery systems in a hotel in Quintana Roo, totaling 1,900 kilowatts and 3,415 kilowatt hours. Started operation just last month, and just in last month is more than 23 tons of carbon dioxide savings, and it is providing benefits to the hotel, to the client, to reducing the energy consumption at peak hours and consuming at base hours. So you consume when the energy is cheaper, and then you reduce your consumption when the energy is most costly. So you having savings in that, and then you are reducing the maximum power you are demanding to the grid at the peak hours. Therefore, you are also reducing one of the key components of the tariff of the fees, of the energy fees. So overall, it's providing about 20% in savings for the receipt of the CFE. So this is also a success case study, just starting operation, and we are working in getting more success studies. Therefore, that's my presentation. So there's my contact information, email, phone, or you can visit the website for the company, and we are happy to having a conversation.